Now, question is finding a number of trials. They don't give you number of trials, then obviously they will tell you to get, they tell you how much, they give you the probability to get that much of probability, how many total trials are required. So that's how the questions generally would be. For example, here, a barcode reader scans correctly with probability 0.93. So this is 0.93, sorry, 0.93. How many independent trials N are needed? In this case, it is straightforward. They asked us N directly. So that the probability of getting, the probability of getting something, we'll get back to this, is at least, probability of getting something is at least is greater than or equal to 0.999. Now let's see what this part is. Probability of what? It should be more than this one. At least one correct scan. At least, so you write X automatically. At least one correct scan. So out of, we don't know how many scans are there. How many scans are required? How many scans are required to get at least one of them? At least one of them should be successful. One of them being successful is greater than this one. I'll repeat it. How many scans are required to get at least one of them successful, and the probability being more than 0.999. I know this is a bit thinking hard question. However, if you try to understand clearly, see, uh, I will explain the context behind it. Probability of a scanner reads correctly 0.93. You have a scanner. Probability that scanner reads the barcode correctly 0.93, meaning it is more reliable. Very good high chance. The probability is 0.93, 93%, meaning it got very good chance that it can read barcode correctly. So here, obviously, you don't need so many number of trials for this to get just one of them, one out of them, to get just one out of them being successful, meaning reading the barcode correctly. So that's the context. That is the context here. At least one of them. It's not all of them. You don't need so many because it will be successful automatically in less number of attempts. Anyways, so however, the requirement for your marks in the examination is, so correct scan is already, see here. This word is there. Link this to this one. At least one. So at least one correct scan is at least one is greater than or equal to one. So they give you the success here. They also mention the success here. So the success criteria is correct scan. How many successes they need? One. You can use calculator directly. However, if you are aiming to get full marks, you need to know this method. Probability more than or equal to 1. If you want to be, so see, you can always draw the number line for these questions, 0, 1, 2, and so on. You know, this is probability of 0 successes. This is probability of 1 success. That is the meaning of this one. This is probability of 2 successes. If you add all the probabilities, that has to be 1. You you can calculate this one directly. However, you can also calculate, if you subtract this one from the total one, that automatically gives you this one. So what I would do is I would subtract. I need anything either one or more than one. What I would do is I will take out 0 from the total. It will give you the remaining. So that is greater than or equal to 0.999. So this calculation, pay attention here. I would rearrange the terms. I would add this one both sides, and I will subtract this one both sides. This becomes 1 minus, I'm doing the step simultaneously. 1 minus 0.999 is greater than, adding or subtracting would not affect the inequality. Remember that. Okay. So this is the step. And now this is 0.001 is more than or equal to P of X is equal to 0. If you interchange the sides, remember this is when inequality changes. There are only two occasions inequality changes. If you change the sides, if you make the left side to the right side and right side to the left side. For example, 2 is greater than 1. If you change them, if you change the positions here, this to here, then inequality changes. Similarly, P of X is equal to 0 is less than or equal to 0.001. Now you need to use the formula here. So formula is NCR, and that's what we are looking for. NCR is 0. P is probability 0.93 to the power of R is 0. We know R is 0 because this is 0. This is always R. And then 1 minus P, which is 0.07 to the power N minus R. N minus R. N minus R is 0 is N less than or equal to 0.001. And now if you continue the calculation here, NC is 0. Anything 0 is 1. NC is 0. Anything choosing 0 is 1. Remember that. And 0.93 to the power 0, that is also 1. And you have 0.07 to the power n less than or equal to 0.001. There are two ways you can do that. In your calculator, you input 0.07. In your calculator, you input 0.07 and you keep raising the power. You keep raising the power until it becomes less than or equal to this one. Yeah, that is right. What I'm saying is correct. So if you should keep raising the power, you may get doubt that when you keep rising the power, value should increase. No, in this case, value decreases because this is decimal. So if you keep raising the power, at some point, it becomes less than this one. Or you can use your logarithms. If you apply logarithms, ln both sides, so it becomes n ln, because the power comes in front of it, 0.07 less than or equal to ln 0.001. So then you divide by this one both sides. Remember, when you divide this both sides, you need to check what this value is. If it is negative, this I told you when we were doing this, when we were changing the sides, you change the inequality. This is the second case. When you are multiplying or dividing by a negative, again inequality changes. So if you go to the calculator and see how much is ln 0.07, that is a negative value, meaning n, because you are dividing with a negative value, it should become n greater than or equal to, now you do the calculation. ln 0.001 divided by ln 0.07. If you do that, you'll get 2.59. N is number of trials. You cannot have decimal number of trials. You cannot scan decimal number of items. It has to be 2 items or 3 items, but it should be greater than this decimal. So n is equal to 3. This is how you do it to get the full marks. If you think you need, although you don't need full marks, but if you need most of the marks, what you can do is, instead of doing this all calculation, so you'll move on from here. So with calculator directly from here, you go to your calculator. In your calculator, you're starting from 1. If you see, you're starting from 1. X is greater than or equal to 1. As x is greater than or equal to 1, you your lower value is 1, you keep checking different values. Here the probability is higher. You don't need so many trials. That's why I started with around 5. Still, that was more than 0.999. More than, that's why I kept on decreasing it. So I went until 3. When it is 3, it is uh, more than 0.99. When it is 4, it was even more than that. So that's why n is equal to 3. You can do this one. Okay. Quickly, I'll explain the next question as well. So here, a pair of 6-sided dice is rolled repeatedly. On each roll, the probability, so there are a rolling pair of dice, probability of getting 6. So you write binomial distribution. N is how many times they roll, we don't know, but probability of getting double 6. Double 6 is the success. You can see the success rate is really really low, because getting double 6 is 1 out of 36 cases. How many rolls n are needed? So that probability, you write this one first. You probability is, I'm directly going here, probability is greater than 0.9, and anyways they will repeat this one, double 6. So I will not focus on this one. I will not focus on this one because I know that is a success. So at least one success, at least one, x is greater than or equal to 1. If you go with the this one I will do calculated method. If you go to the next one, if you see, I started with lower 1 because you want to see starting from 1 until what number will make us bigger than 0.9. So I started with 1 because it is a rare case. To see the success, we need lots of trials because it is having very less probability. That's why I went until 60. Still, it was not enough. It was not exceeding my requirement. My requirement to exceed is 0.9. And the catch here is, always see here, we are checking starting from 1, and we don't know what value here will make us bigger than 0.9. So you keep upper and number of trials, both are exactly the same. You keep upper and number of trials, both of them are exactly the same. And probability 1 divided by 36, it automatically converted into this decimal, and at this it exceeded 0.9. That's what we are looking for. So it is 82. It is 82. And now try this question. Pause your screen. Pause the video, pause the video and try this question. And you have the answer here.